How do wet labs compare to dry labs for grad school research? Imagine stepping into a space where you get your hands dirty with chemicals and biological samples, or a room filled with computers analyzing data. Both environments are essential in graduate research, but they serve very different purposes. Wet labs are physical spaces equipped for experiments involving liquids, biological materials, and chemicals. They have safety features like fume hoods, sinks, and ventilation to handle hazards safely. In these labs, students perform hands-on work such as growing cells, running chemical reactions, or dissecting biological tissues. This kind of research is often slow but detailed, requiring patience and precision. It's perfect for projects like studying disease mechanisms or developing new drugs, where real biological samples are necessary. Dry labs, on the other hand, focus on computational work. They are set up with powerful computers, data storage, and software for modeling, simulations, and data analysis. Instead of working directly with physical materials, students in dry labs analyze large datasets, write code, or create models to test hypotheses. This type of research can be faster and more cost-effective because it doesn't need expensive chemicals or lab equipment. Fields like bioinformatics, computational biology, and systems biology relying heavily on dry labs. They are ideal for projects that involve analyzing genetic data, running simulations, or developing algorithms. Choosing between a wet or dry lab depends on your skills and interests. If you enjoy hands-on experiments, working with biological or chemical materials, and following safety protocols, a wet lab might be the best fit. If you prefer working with data, programming, and running computer models, then a dry lab environment suits you better. Some graduate programs even combine both types, giving students a chance to gain experience in experimental and computational methods. This can be especially useful in interdisciplinary fields where understanding both aspects is valuable. Cost is another factor to consider. Wet labs tend to be more expensive to run because of the need for chemicals, safety equipment, and maintenance. Dry labs usually have lower operational costs but requiring investment in high-performance computers and software licenses. The type of research question you want to pursue also influences your choice. For example, drug development or biological research usually needs wet labs, while data analysis or modeling fits dry labs. In summary, wet labs are all about hands-on, experimental work with biological and chemical materials, fostering collaboration and real-world data collection. Dry labs focus on computational analysis, offering speed and efficiency in processing large datasets and creating models. When choosing your research environment, think about your skills, your research goals, and what kind of work excites you most. Both options are vital in graduate research and can even be combined for a well-rounded experience.